Finally, this is my lab 4. The aim of this lab is to examine and predict the motion of a spring mass system. And the setting is the mass swings horizontally and oscillates vertically on a spring. And here are the physics principles. The spring force is equal to spring constant times the changing length of the spring. Kinetic energy is 1/2 mass times speed squared. Gravitational potential energy is mass times g times height. Spring potential energy is 1/2 spring constant times the changing length of the spring to the power of 2, and the total energy is just the sum of the energies. Net force is equal to rate of change of velocity times mass. Spring constant is equal to 4 pi squared times mass divided by period to the power of 2. And for what is the main question, I calculate the periods for x and y axis. I use the data from tracker. So I use the t-value for this point minus the t-value for this point divided by the number of periods between these 2 points. Just as shown on the PowerPoint, I use this formula. And I find there is a discrepancy between these 2 values, and I still need to figure out why is that. And for the initial data of the computer model, the mass of the object and the initial length of the spring are given by the video. The position of the ball is the first line of tracker data. The velocity is initially 0. And for the spring constant, I plug in the numbers and get the value here. The time period I used is the period for y-axis. And let's look at the code. So the length of the spring is the position of the ball minus the position of the spring head. And L head is just L divided by its magnitude. S is current length of the spring minus its original length, and K is kinetic energy, UG gravitational potential energy, US spring potential energy, and E total energy. And those 4 energies are calculated using these 4 formulas here. And the gravitational force is mass times g. The spring force is using this formula here. Notice that there is a negative sign here. That's because L hat is directed downward. However, the spring force is directed upward. And the net force is the sum of these 2 forces. And then I use the Newton's second law to update the position of the ball. And then I calculate the changing energies, which I will plot in a minute. And then we run this program. I put the x, y values in a CSV file. This is the animation, and here are the graphs. So the green line is the spring potential energy. The red line is the gravitational potential energy. They're approximately of the same magnitude, however, they're in different phases. For the blue line, it's the kinetic energy, and it's gradually getting smaller. And for the orange line is the total energy, which remains at 0. That is due to the conservation of the energy. And here are the graphs for x, y positions vs time. The red line is the actual motion, and the blue line is the predicted motion. They are similar, however, there are still discrepancies between these 2 lines, which I need to figure out later. And for the conclusion part, first, let's summarize how to predict the motion. We need to find the net force by adding the gravitational force and the spring force. And we use the net force to find the ball's position using Newton's second law. And I still have room for improvement. First, I need to find out why there is a discrepancy between the periods of x and y position, as I mentioned in the what does it mean question. and that might be the cause of the difference between the actual motion and the final actual motion and the predicted motion on the closed grip. And also I can count the effects of the L resistance to make my prediction more accurate. Thank you.